I am Manika Sri, Assistant Professor, Shakti College of Arts and Science for Women, Ottanjatram. Today we talk about photochemistry. Photochemistry is the study of the interaction of electromagnetic radiation with matter resulting into a physical change or into a chemical change. Primary process. One molecule is excited into an electronically excited state by absorption of photon. It can undergo a number of different primary processes. There are two primary processes are available. First, photochemical process. Next, photophysical process. The photochemical process are those in which the excited species dissociate or isomerize or rearrange or react with one another molecule. Photophysical process include the radiative transition, in which the excited molecule emit the light in the form of fluorescence or phosphorescence and return the ground state. An intramolecular non-radiative transition takes place. So we see about laws of photochemistry. First, we see about Lambert's law. This law states that decrease in the intensity of monochromatic light with the thickness of observing medium is proportional to the intensity of incident light. That means minus dI divided by dx is proportional to I. I is the intensity of transmitted light. So it is denoted as minus dI by dx is equal to ki, which on the integration give I is equal to I naught e power minus kx. I naught is equal to intensity of incident light, I is the intensity of transmitted light, k is the absorption coefficient. Next we see about Bayes' law. It states that decrease in the intensity of monochromatic light with the thickness of the solution is not only proportional to the intensity of the incident light but also the concentration of the solution, mathematically described as minus dI by dx proportional to IC. Minus dI by dx is equal to epsilon IC, which on the integration gives I is equal to I naught e power minus epsilon Cx. Epsilon is equal to molar absorption coefficient or molar extension coefficient. Next we see about Kirchhoff's law. Only the light which is absorbed by a molecule can be effective in producing photochemical changes in the molecule. Next we see about Stark-Einstein law. It states that for each photon of light absorbed by a chemical system, only one molecule is activated for a photochemical reaction. The energy absorbed by one molecule of the reacting molecule is given by E is equal to NH mu. This energy is called 1 Einstein. The numerical value of Einstein is given below. In GCS unit, E is equal to 2.86 calorie per mole or 2.86 into 10 power 5 divided by lambda A naught kilocalorie per mole. In SI unit, E is equal to 0.1197 divided by lambda joule mole power minus 1 or 11.97 into 10 power minus 5 divided by lambda kilojoule mole inverse. The interpretation of Einstein law. First we see about the quantum efficiency. The quantum efficiency is equal to number of molecules reacting in a given time divided by number of quantas of light observed in the same time. Experimentally, I is equal to rate of chemical reaction divided by quanta observed per second. Next we see about quantum yield. In the photolysis of chlorine and hydrogen, the quantum efficiency can be high as 1 million. Chlorine react in the presence of light gives a chlorine radical. So Cl react with the hydrogen to give them HCl and hydrogen. Hydrogen react with the Cl2 react to give them HCl plus hydrogen. In the photolysis, bromine and hydrogen, the quantum efficiency is very low, that is 0.001. The bromine react in the presence of light to give two bromine molecule. So Br react with H2 give HBr plus hydrogen. It is the endothermic reaction. HCl reaction is the exothermic reaction. So hydrogen radical react with the bromine molecule to give HBr and bromine radical. So next we see about luminescence. The glow of produced in the body by method other than the action of heat, that is the production of cold light, is called luminescence. It is divided into three types. First, hemiluminescence, the emission of light in chemical reaction at ordinary temperature is called chemiluminescence, that is the light emitted by glowworms. The certain substance, when exposed to light or certain other radiation, absorb the energy and then immediately start re-emitting the energy. Such substances are called fluorescent substance. This phenomenon is called fluorescence. Example: the organic dyes as eosine, fluorescence, etc. The vapor of sodium, mercury, iodine are shown the fluorescence. Next, we see about the phosphorescence. There are certain substances which continue to glow for some time even after the external light is cut off. That's called the phosphorescence. It is a slow fluorescence effect. The fluorescence and phosphorescence in terms of excited electron. The excited species can return to the ground state by losing all its excess energy by any one of the parts shown in the Jablonski diagram. So singlet of ground state is S0, the singlet excited state is S1. The pair of electrons with the opposite spin but each in different orbital. In triplet excited state, the pair of electrons with the parallel spin in different orbitals. Next we see about photosensitization. Photosensitized reaction, an electronically excited molecule can transfer its energy to a second species which then undergoes a photochemical process even though it was not itself directly excited. Mercury acting as a photosensitizer. Mercury reacts in the presence of light, it's give them mercury radical. Mercury radical react with the hydrogen molecule give mercury and hydrogen radical. The chlorophyll acting as a photosensitizer. CO2 react with the water in the presence of light gives glucose and oxygen. A photochemical equilibrium A is gives B. It's a light and thermal equilibrium nature. The rate of the forward reaction I absorption is equal to K1 into I absorption. The rate of backward reaction is equal to AB is equal to K2B. At equilibrium, the rate of forward reaction is equal to the rate of backward reaction. So it is denoted in the equation K1 I absorption is equal to K2 into concentration of B, or K1 divided by K2 divided by K1 is equal to I absorption divided by concentration of B, or K is equal to I absorption divided by the concentration of B, where K is equal to K2 divided by K1. It is the photochemical equilibrium constant. Thank you.